There are various types of activation functions, and Relu is one of the popular ones. In short, Relu is my favorite activation function due to its ability to avoid problems like vanishing gradients that occurs with tanh or sigmoid. In this video, I'm going to explain Relu deeply and intuitively in the way that you will understand. And trust me, you'll never forget Relu anymore. Relu stands for rectified linear units. If you go to the internet to search about Relu, you might see something like Relu is an activation function that introduces non-linearity, allowing models to learn more complex patterns. Now, this might sound a bit too technical, which is why I'm going to use an analogy to explain. Let's say we have a woman and in her house, she lives in a house and she has a little child of maybe 10-year-old, and this woman is probably 48 years old. She has a door, and the door has a caption like push. And you mostly see these doors in the offices, in malls, and other places that you visit. The door requires pressure. Without pressure, this door doesn't open. You don't just touch the door and it opens. You have to apply pressure and the door gets to open. So every morning this woman goes every morning when this woman wants to go out, she applies pressure. She pushes the door with force and the door gets to open. The woman goes to whatever she wants to go to. And one thing is that this little baby or this little child has been watching the mother every day, how the mother attempts to like push the door and the door opens. So one beautiful day, the woman was still in the house with the mother, but the daughter approached the door and she tried to push the door. When she tried to push the door refused to open. So we have a Relu formula, perhaps you could say we have Relu to be f of x equal to max of 0, this is bracket, max of 0, and we have x here. So that means we have f of x equal to max 0 of x. And when this child approaches this door, watch and see what happens. We have this, let me draw a little graph here to explain it mathematically, and this. So we have this little child, this is the little child. So we have -1 and we have -2 over here. So this little child has this color. The little child has blue over here. This is the little child. The child comes close here and boom to this point, -2. Now what does Relu say? Relu says no, you are bringing in negative value and f of -2 is equal to max of 0 and -2. So what does this happen? You can clearly see the max function, and the max function simply means it will always return 0 as the maximum if the value is less than 0. And you and I know very well that -2 is less than 0. So the answer will always be 0. The door is open, and that's how the door works. The door says, no, I can only open when your value is higher than x. I can only open when the pressure is enough, but when the pressure is negligible, I can't open this door. And that's how it really works. So the child tries again, and she tries again, she pushes the door to -1. The same thing happens. It is still going to be 0 because f of -1 equals to max of 0 and -1 is still 1. Now the mother, after observing what happens, this is the mother. The mother decides to come and say, oh, my daughter, she approaches, she gets to 0, and immediately she reached this point. Phew. You see what happens? The door opens. The door opens at points, maybe 0.3, can be 0.1, can be 0.3, can be 0.2, as the case may be, and we also have 3 here. So this door gets to open. How does the door open? Because we have f of 3 equal to max of 0 and 3. Oh, you and I know very well that 3 is greater than 0. So what happens? It becomes 3. The magic door opened because she has been able to apply a significant amount of pressure that can actually open the door. And that's what happens, and its abilities to solve problems like vanishing gradients. It works in a non-linearity. So like the technical term would say, it's non-linearity. Simply means that it's not in a straight line. It works in this way. And this is what helps it to basically learn more complex patterns. And that's how it works. So always remember, Relu is an activation function that helps to avoid vanishing gradient problems, of which sigmoid and tanh can't avoid. With Relu, training deep learning model makes it easier. Thank you very much for watching. My name is Ofyong Basi. Goodbye.